In this video, I want to give you a short introduction to solving one-step equations, specifically by using addition and subtraction. And we're going to look at 4 different examples, and each example is going to lay down a foundational principle that's going to be important later on, especially when these equations get more difficult. All right, so this first equation we're looking at, x is some variable, some unknown number, and from x we're going to subtract 8, and when we do so we get 3. All right, you probably know already what the number is. So looking at this example, we have x minus 8 equals 3. And so remember, the goal of solving equations is to isolate the variable. And our variable in this case is x. But you'll notice on this side of the equation, along with this x, we have this minus 8. So what we're going to do is use inverse operations to isolate this variable x. So since x is being subtracted by 8 on this left side, let's go ahead and do the inverse of subtraction and add 8. But of course, whatever we do to one side of the equation, we must also do to the other side of the equation to keep everything nice and equal. So what we've done here is use the addition property of equality, which states that when you add the same value to both sides of the equation, everything stays nice and equal. So what happens on this left side is the negative 8 and the positive 8, of course, cancel out. So I'm left with just that x, and that's what I'm going for. So x equals, and we'll simplify this by going ahead and doing this addition. So 3 plus 8 is 11. And probably you saw that the value of x was going to be 11 before we ever took any of these steps. But again, and I cannot stress this enough, learning these steps early on for these easy problems will make your life easier when these problems get more difficult. In this second example, it looks like the variable for which we're solving is y. And over here on the left side, I have 4 plus y. And when I do this addition, I get negative 7. So what will this value for y be? Well, let's go ahead and work our properties of equality and isolate this y. Okay, so looking at this 4 plus y, well, what am I going to do? Well, I need to get rid of this 4 so I can get this y all by itself. But the 4 doesn't have any operation symbol in front of it. Are we adding 4, subtracting 4? It just looks like there's a 4 and we're adding y to it. Well, remember that addition is commutative, which means it doesn't matter the order we do it in, you still get the same answer. So 4 plus y is the same as y plus 4. So if you would like, think of it this way, that this really isn't 4 plus y, you can also call it y plus 4. Well, at this point, I think it's pretty obvious as to what we're going to do. Since we are trying to isolate this y and we're adding 4 to it, let's go ahead and do the opposite of addition and subtract 4 from both sides. So once again, whatever I do to one side of the equation, I must also do to the other side to keep everything nice and equal. And that's called the subtraction property of equality. So let's go ahead and do this subtraction. On the left side, those 4's will cancel, and it will leave me with just the y. And on the right side, let's go ahead and do this simplification. So negative 7 minus 4 will be negative 11. So in this second example, when I plug negative 11 back into y, 4 plus a negative 11, let's go ahead and write that down, 4 plus a negative 11, well, when we add a negative, we're really subtracting and then keeping the sign of the larger one. So 11 minus 4 is 7, and keeping the sign of the larger is negative. So we see that negative 7 equals negative 7, so I know it works out. So the value for y that makes this equation true in this second example is negative 11. In this third example, we have the equation negative 3 equals m, which is our variable, our unknown value, plus a negative 2. Well, I'm not sure I like the 2 operation symbols right next to each other, the addition with the negative here. So I'm going to go ahead and rewrite this equation. And whenever I have plus a negative, I'm going to change that to a minus. So it'll be m minus 2 on that right side. And that's probably a little easier to work with. So what am I going to do now? Well, I'm trying to get this m variable all by itself on this right side. So right now I see that m is being subtracted by 2. So what's the inverse operation of subtraction? Well, that'll be addition. So let's go ahead and add 2 to both sides of my equation. And once again, that's called our addition property of equality, which just states that when I'm adding some value to one side of the equation, I need to do it to the other side, and it'll keep everything nice and equal. So over here on the right, we see that the -2 and the +2 cancel out. So on this left side, when I go ahead and do this simplification, -3 plus 2, well, that's going to be a -1, and that's going to equal m. Well, some students at this point don't like to have this variable over on the right side of the equation. They would prefer it to say m equals -1 instead of -1 equals m. Well, you can go ahead and switch these two sides of the equation around and say that m equals -1. And there's a property of equality that allows us to do this maneuver, and it's called the symmetric property of equality. And that just states if these two expressions on the left side and the right side are equal to each other, then I can go ahead and exchange them, the left one for the right and the right one for the left, just like we've done, and everything is nice and equal and stays the same. In this fourth and final example, we're going to go ahead and look at an equation here that includes fractions, because what would a good math video be without a problem with fractions? And so we see that we're going to isolate this variable n over here on the right side. So similar to a previous example that we looked at, we have 2/3 plus n right here. And again, some students get a little confused because they don't see a sign in front of the 2/3. Well, realize here that this 2/3 is positive, and remember that 2/3 plus n is the same as n plus 2/3. So really what we need to do is the opposite of adding 2/3. So that's going to be subtracting 2/3 from both sides of this equation. And once again, this is called the subtraction property of equality that allows us to do this. And we're just going to go ahead and subtract 2/3 from both sides. And when we do that, we'll keep everything nice and equal. So on this right side, the 2/3 will cancel out. And so we're left with just our n, so that's good. But over here on the left, we have 3/8 minus 2/3. So obviously, it's not as simple as doing integer addition or subtraction. We're working with fractions, so we'll need to get common denominators here. So between 8 and 3, it looks like my common denominator will be 24, just multiplying them together. So for the 3 denominator, I'll need to multiply by 8 over 8. And for the 8 denominator, I'll need to multiply by 3 over 3 to get common denominators and kind of fix those numerators so everything stays nice and equal here. Basically, we're just scaling these fractions. So in the first one, 9 over 24 minus, it looks like 16 over 24, and that's going to be n. And when we do this, our common denominators of 24, 9 minus 16 is -7 over 24, and that will equal n right there. And once again, as we stated previously, sometimes students don't like to see this variable isolated on the right side, so we can just go ahead and switch these two. And do you remember what property that is? Yeah, it's the symmetric property of equality. And we can just switch those two sides, and there's the value for n in this final example, -7 over 24.